These are the notes for section 4.1, organizing data into matrices. So a matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. So matrices are commonly written in box brackets, but sometimes you can see them with the regular parentheses. But box brackets are way less confusing, so we're going to use those. The horizontal and vertical lines of entries in a matrix are called rows and columns, respectively. So horizontal is rows, vertical is columns. The size of a matrix is defined by the number of rows and columns it contains. So a matrix with m rows and n columns is called an m by n matrix, where m and n are its dimensions. So the dimensions of the following matrix are 2 by 3 because there are 2 rows and 3 columns. So that matrix would look like this. A equals 1, 2, 3, 4, 5, 6. So with matrices, what we like to do is we like to use capital letters when we're naming a matrix. And then when we talk about individual items, we use lowercase letters. So if I wanted to talk about one item there, I'd designate it using a variable with 2 subscripts. For instance, a sub 2 comma 1 represents the element at the second row and first column of matrix A. So a sub 2 comma 1 of this matrix here would be the second row and the first entry, which is 4. And it's kind of cool because you use the lowercase to talk about elements and the uppercase to talk about matrices. It's a nice little notation. In general, matrices with dimensions m by n can be expressed in the following way, or would be expressed in the following way. And these can get really, really big. But the first entry in this first corner is always a sub 1 comma 1, and then it'd be a sub 1 comma 2, and then it'd be a sub 1 comma 3, and this would just keep going until we got to a sub 1 comma n, because that's the nth column there. And then you can go down as well, so this would be a sub 2 comma 1, a sub 3 comma 1, and then you'd go downwards until you get all the way to a sub m comma 1. And these go diagonal as well. This would be a sub 2 comma 2, a sub 3 comma 2, and then a sub m comma 2. Some dots in there. We can go this way as well. A sub 2, so row 2 comma column 3, a sub 3 comma 3, and then we're going to go down to a sub m comma 3. And then this way, we're going to keep going till we get all the way to a sub 2 comma n, all the way to a sub 3 comma n, and then down this way diagonally, and this way, our final entry in the lower right hand corner would be a sub m comma n, which is kind of a nice way to represent it. And you might see a notation where it talks about a sub I comma j. It's just the ith row and jth column. Ith row, jth column. So for some vocabulary, just because it's useful to have, a row vector, which we don't really use all that much, but it's kind of cool, is a matrix with only one row. A column vector is one column. A square matrix is where m is equal to, well, n is equal to m. Okay, so the dimensions are square. So it's 4 by 4, 3 by 3, 2 by 2, so on and so forth. And then the empty matrix is one with no entries, which would be like that. So this is the empty matrix, no entries. So thank you guys for that. Make sure you answer all the questions.